Good afternoon, everybody. This video here, we're going to talk about not the bell ringing, but we'll talk about heat flow rate through a substance. So hopefully by now we have an understanding that, and maybe you knew this before you took physics this year, I don't know, but heat always flows from areas of hot to areas of cold. All right, and so with that in mind, if you think about this concept here, we're talking about how much heat flows through a particular substance. If you think about real world applications, for example, if you're cooking something, all right, or you're getting a hot a hot casserole dish or whatever out of the oven, obviously you're not going to use your bare hands. You don't want to get second-degree burns, I wouldn't think. So what do? You put on oven mitts of some sort, and reach in the oven, grab that casserole dish, set it down, and ideally you're not burning yourself through the oven mitts, burning your hands through those oven mitts, because the material of that oven mitts is absorbing some of that heat that's radiating from the casserole dish to your hands. So this could, has of course a wide variety of applications here. But what we're going to look at here is how to contend with this formula. It looks a little bit daunting, but it's really not all that bad. And I am going to show you how a whole slew of these units cancel out. So what we have here, we have Q sub H equals K times A times delta T over L. Just as a quick review, remember that delta T is one variable. All right, it's not delta times T, it's just delta T, saying that, by the way, the temperature difference, all right, there's a temperature difference. In other words, the temperature is changing from one reading to something else. Now, Q sub H, heat flow rate through a substance. All right, that's what the Q sub H stands for. K is thermal conductivity, and I'm going to talk to you about that more here in a second. A is surface area. As I just said, delta T is temperature difference, and L represents the thickness of the substance. If you think about it, if this is, I don't know, my phone here represents the heat source, and it's radiating this way, going that direction, then what's happening is if I have a thinner thickness here, let's say that the thickness of the substance is like 3 centimeters. Well, it's not going to take quite as long, and you're going to have more heat traveling through that 3 centimeter area, as opposed to if it was something like, let's say it's like this, let's say it's 13 centimeters, right? You're going to have a higher heat flow rate with a substance that isn't quite as thick as other substances are. So let's get this chair out of the way because I don't want to trip over it and really end up on YouTube for the wrong reasons. So kind of a lot going on here, but it's really not all that bad. And there's going to be a whole slew of units up here, and you're going to see how most of the slew of those units cancel each other out. So I am going to show you that as well. Now, the information about the thermal conductivity. On the instructions, actually no, I did change that. But what will happen is the thermal conductivity is typically a number that's provided in a chart. Just like with the previous video that I posted here about heat of vaporization, heat of fusion, heat of vaporization. The same idea, you're going to have to look up a number, but you're really not going to necessarily you're going to have to look up the number, but it's going to be right there attached to the document in Google Classroom. And I'm pretty sure I said in the directions there, if you scroll down like to page 2, you'll see a chart there. In fact, it's on the back, it's just after question number 9. All right, and basically it has the thermal conductivity for all the different materials that are provided, that are listed in the various problems on this document. So what we have here is, again, this formula, you got one variable here, delta T. So we're going to go ahead and work through a problem here. So a slab of concrete is 12 centimeters thick and has a surface area of 37 centimeters squared. The temperature on one side is 25 degrees Celsius and it's a temperature of 20 degrees Celsius on the other side. What is the heat flow rate caused by the temperature difference across the substance? All right, so what's that heat flow rate? So here's how you set up the problem. So first of all, you look for concrete in the chart, and when you do, you'll see this number, 2.07 times 10 to the minus third. Now, what I did was I wrote it out like this in scientific notation, but I also wrote it out in decimals. So if you're not, maybe you're not sure how to deal with scientific notation on your calculator, or you're not comfortable with it, you have the decimal number written there as well for you. Now, don't get too bent out of shape about all these units here, but I'm going to put all these in just because. So you got calories dot centimeters, and we're going to use a little bit thicker marker here, because that seems to be fading just a tad, over seconds dot centimeters squared dot degrees Celsius. All right. So this is all the K value. Again, this is from the chart. We're going to multiply that by the area, which, as it's shown there, is 37 square centimeters. And then you have your temperature difference. Well, again, it was 25 on one side and 20 on the other, so you subtract the two, because why? We're looking for the difference, and we get 5 degrees Celsius. This is all just the numerator, right? Notice all these units here. We're going to divide all that by the thickness, which in this case happens to be 12 centimeters. Now, what you do before you just multiply this out, I'm going to go ahead and cancel out a lot of these units, and you'll see what I mean when I say that most of these units disappear. So what you do, you look for the units that exist in a pair and you get rid of them. So I've got centimeters here and here. They're out. They are the weakest link. Goodbye. Then you have centimeters squared here, and you have degrees Celsius. All right, so all those units are gone. I am left with calories per second. So when I multiply across the top and divide by 12 on the bottom here, I'm going to be left with something calories per second. Can you see that all right? I don't know. Let's say you can't, because for whatever reason, that marker is kind of fading, looks like. All right, so that's calories per second. Pardon my not so good penmanship going there. All right, so then you multiply this. Let's see, calculator. I don't know about you, but I'm not going to do all this math in my head when you got yourself a calculator. You're probably using your phone, but hey, whatever works for you. So 2.07 times 10 exponent negative 3. We're going to multiply that by 37 times 5. We're going to get a pretty small number. Then we're going to divide that by 12 and get an even smaller number. And that smaller number comes out to be 0.0319 calories per second. All right, calories per second. All these problems are done the exact same way. Okay. Now, if you think, let's just use some intuition here. If like I said earlier, the thickness is basically, I don't want to say it governs everything, but it plays a significant factor. Okay. So if I increase the thickness here from 12 up to 17, what's that going to do to this number? It's obviously going to reduce it, all right? Because you have, instead of a thickness of 12 centimeters, now you have a thickness of 17 centimeters, all right? So the heat flow rate is going to be reduced. That's going to reduce this number. Conversely, if I decrease this number from 12 to, let's say, 5, then that's going to increase this number, because the heat has a smaller area, smaller thickness of the material through it that it travels through. Is what I'm trying to say there. Whoops. Now, and that's true basically, if I change the surface area or I change the temperature difference. All right. The more I increase the temperature, or the more I increase the temperature difference, that's obviously going to change this as well. All right. But all you really need to be concerned about here is making sure you set up these problems correctly. All right, making sure that you have a conductivity first, and again, that number is provided on page 2 of your document. You'll see it, hopefully. Then you have the surface area, and you have the temperature difference. Your job, figure out the temperature difference. You got two temperature values there, and I saw this on the heat energy transfer paper, or worksheet rather, where a few of you used one of the numbers, one of the temperature values, and instead of finding the difference. Remember to find the difference. So in this case, 25 minus 20, that's how I got that 5. So remember to find the temperature difference. So K, thermal conductivity, look for it on the chart, times A, the surface area, times the delta T, temperature difference, divide all that by the thickness. So now, and really what you're doing is you're multiplying 3 numbers together and then dividing by the 4th number to end up every time solving for Q sub H. Okay, so it's just heat flow rate through a substance. And all these problems are done the same way. You're just going to solve for the heat flow rate through a substance. I'm not going to have you solve for anything else. I'm not going to get too crazy with algebra here. And as always, you'll be asked to write out the formula. You don't have to draw the box around delta T, but again, I'm doing that to show you that this is one variable. And then make sure you define the variables, just like I did here. You know, heat flow rate through a substance, Q sub H, so on and so forth. You do not, and I appreciate some of you going above and beyond, but it's not necessary. I mean, when you define the variables, the way I did it here, that's fine. All right, that's all I'm really looking for. Just understanding that, okay, A is surface area and delta T is temperature difference, and so on and so forth. So give this a shot, and if you run into some problems or whatever, that's fine. Just let me know. I will tell you this: some of the answers on this particular assignment will be really small. I mean, like this is pretty small. All right, this is less. It's like 3 cents. All right, think of it in terms of money. If you want to think of it in terms of a percentage, it's like 3%. But like I think it's number 2. You're going to have a really, really small number. All right, just FYI. And then 3, 4, and 5. Well, 3 and 4 are a little bit bigger numbers. Same thing with 6. 5 is a small number as well. So it's basically all over the board. But if you're doing this and you run into, you're not sure what's going on, just email me. If it's during the school day, I'll pretty much see it right away. If you email me in the evening, don't expect a response from me until the following morning. So, take care of this and get it done, get it turned in. And just remember, you also have weekly center response number 24. That was assigned today. Due next week. Weekly center response number 23 is due this Friday. Coincidentally, it's April 23rd. So, that's all I've got. So, if you need anything, just give me a holler.